This video is going to give you an introduction to comparatives and inequalities. If you take a look at this example here, first I want to point out this definition up at the top. A solution is just a value that makes the inequality true. This isn't the first time we've heard this word, but just so you kind of have a heads up there. So it says which of the given values are in the solution set for x is less than 2. So literally what I want you to do is substitute in this number into the inequality. So I'm going to write 0 is less than true. So is that a true statement? Is 0 less than 2? Yes. So I know that A is going to work. Okay, so let's look at x equals -3. Again, we're going to plug it in. -3 is less than 2. Is that a true statement? Yes, it is. And I'm thinking about this also on the number line. Here's -3, -2, -1, 0, 1, and 2. I notice that -3 is less than +2. So I know that that is also going to be a solution. How about -5? Same thing. -5 is less than 2. That is a true statement. True. So I know that that is also a value for the solution set. X equals 2. Okay, 2 is less than 2. Is that a true statement? No, it is not. 2 is not less than 2. In fact, 2 is actually equal to 2. So this is going to be false. It is not a true statement. So I'm not going to mark that one. Then I have x equals 5. Again, I'm going to plug it in. Is 5 less than 2? Nope. That also is false. Pretty easy to see there. And then I've got -5/3. So I'm going to plug this in. -5/3 is less than 2. Is that a true statement? If the improper fraction is throwing you off, let's make it into a mixed number, or even just thinking about it as what whole number is it going to be closest to. So -5/3, I know that if it was -6/3, that would be a -2, but I still see that I've got a negative here. Is a negative anything going to be less than a +2? Yes. So I know that this also is going to be true. If you take a look at the inequality notations here, when we talk about graphing, you can use this as a little cheat to kind of help you. So greater than or equal to, less than or equal to, it's going to be a closed dot when you graph it. And when you write your solution set, you're actually going to be using brackets to show that. Greater than or less than is going to be an open dot, and I'm going to be using just normal parentheses. And whenever we talk about negative infinity or positive infinity, I'm going to be using an arrow. So something that looks like this, or it could possibly even look like this. And whenever I'm talking about infinity, because I can't narrow down and say exactly what number it is, we're going to be using our parentheses because it's going to tell us that we can't exactly pinpoint that starting or ending number. A few other things about when you're writing interval notation. So you're always going to write the smaller value first. So for example, here's what I mean by that. We have x is less than 4, and that means that x can represent any value from -infinity all the way up to 3.999999999, and it would keep on going forever. So to write this as an interval notation, I want to think about what number would come first, what number is the lesser value. Negative infinity is going to go first. Again, because I'm going to be using just a normal parenthesis because I'm using an infinity sign, a negative infinity, which tells me that I can't exactly narrow down that starting point. Then I'm going to put a comma, and then I know that it's going to go all the way up to 4, but again, this parenthesis lets me know that it's not exactly 4. It's going to go all the way up to 4, but not quite touch it. Notice that we would not write 4 comma negative infinity because that negative infinity is the smaller value, and that's smaller than 4, so we're going to write that first. I hope you found this video helpful.